Welcome to the introduction to your Groundwater Lab. This week, we will be looking at how deep the groundwater is below the surface and how relevant that might be for thinking about a new home site and what kind of depth of well you might need to drill to have a reliable resource, a reliable drinking water resource into the future. We'll also think about another context where the goal is to, on a societal level, have safe, clean drinking water for a hypothetical town, despite having a few locations nearby in the landscape where there is contamination being introduced into the subsurface, into the groundwater. And then finally, for part C of today's lab, we're going to look at some of the actual data using an online database that's interactive for the local area, for sort of Fresno, Madera area, and see how deep the water table is in different places, what a little bit of the variation of that data set is. So let me go ahead and share my screen with you, and we'll get started looking at the lab. In this lab, the goals are to identify where the groundwater table is and evaluate how the groundwater is flowing in the subsurface. You'll also analyze contamination and how it is getting into the groundwater and where, therefore, it is safe to get drinking water for a township. And then finally, you'll, in part C, take a look at some local data through the interactive online map. When we think about groundwater being in the subsurface, we know that it's not water that's ponded at the surface. So we're not talking about lakes or rivers. We're talking about water that has percolated down, it's infiltrated down into the subsurface, and it's being held by soil or by rock. If it's actually within rock, we call it an aquifer. And otherwise, in general, just in general, we're talking about groundwater and the water table. Specifically, when we get down to the depth at which there is actually water present in the subsurface, then we know we've reached the water table. Below that is the saturated zone of groundwater in the subsurface. So one way we think about and display groundwater data is using a contour map. We've seen contour maps, topography maps before when we've been looking at the surface of the earth and the shape of the land. And then we know that those contour lines follow the shape of the land, so that if you walk along a contour line, you're at the same elevation at all times, right? And so you can look at the contours, those curves on the map, to understand how the overall land is shaped. We are doing the same thing, but now we're looking at the subsurface. So we're not looking at, here we go, the surface of the land, right? But we're actually looking at the elevation along the top of the water table itself in the subsurface. So you still have contour lines here. We have 810 meters above sea level. Here is 805 meters above sea level, 800, 795. So that we can see that in general, as we go from A to B, right? So A over here in the west side of this map, B over here on the east side. As we go from A to B, we're generally going downhill within the water table itself. We don't know what's happening at the surface. The surface elevation might similarly be going downhill in that direction. It might be going in the opposite direction for some reason. But what we're concerned with is the elevation of the water table, the top of the water table, the saturated zone. So these arrows are showing you the direction of flow of groundwater in the subsurface, because just like at the surface where streams flow downhill due to the pull of gravity, water in the groundwater table is going to flow downhill due to the pull of gravity. So if your water table is at a higher elevation in one area than it is at another area, so the top of the water table is different, there's overall going to be a trend for the water to move downhill towards the lower elevation portion of the groundwater table itself. So these arrows are showing you that in general, water is moving within the groundwater table from west to east in this area. But there is some variation. We always draw the direction of flow perpendicular to the groundwater contour itself. So water is going to be moving directly downhill, perpendicular to the direction, the line, the contour line itself. This example is what you'll be calculating in one of the upcoming questions. So this gives you a visual with numbers associated with it, way to think through an example of the calculation you're going to be doing. One of the things you'll be doing here is drawing in a contour line. So that's what you're asked to do for question 1, part A, near the house site that you're considering. So this X marks the spot is the house site that you are thinking about putting in, and you're thinking about how deep of a well do you need to drill in this location to have a reliable drinking water resource into the future. And so part of drawing a contour line is to stay within the contour lines that are already there, because again, you'd want to have a contour that if you walked along it, you're always at the same elevation. So you can't cross another contour line. And you also want to follow the data that you're given as closely as possible. So for a few different things in this lab, you'll be using the draw feature. So choose whatever color you want. And I'm going to draw an example contour line. You're going to draw one near that house site, but I'm going to draw one at 806 meters elevation. So there's 2 data points that are actually at 806. And then you'll see here there's 807 and 805. So I know I need to go between those at that point. And then in this area, I don't have any specific data, but I know I need to stay between the 2 contour lines that are already there. So this is how I might choose to draw my 806 contour line. Here I'm going to go between the data points that are available, and then I'm staying between the contour lines. So that's how you might draw an additional contour line onto here. And it's also asking you to draw in arrows. You always want to draw those perpendicular to the line. So a couple of example arrows are there, there, and here. So those would all show the direction of flow of water in the water table along that contour line. So you'll do something similar near this housing site, and you'll answer a couple questions about how deep is the water table, what information are you getting from that. Part B is looking at a similar contour map of the water table itself. So again, not the surface of the land, but the top of the water table. And here we're looking at elevations that are in general decreasing from north, in this case, down in general to the south. So if we were to draw some representative contour lines here, which is something you are asked to do in some detail actually for all of the contour lines, but I'll just do it for one, you would make sure that the arrows are pointing downhill and that they're perpendicular to the contour line wherever they cross it. And you'll notice that this means there is some variation in direction, but that overall, again, there's a trend, and that trend is that the water is moving from north to south in this area, this hypothetical area. So part of what you're doing here is doing some interpretation like that of showing direction of groundwater flow, but then you're using that information once you have it visually on this image to think a little bit about the different opportunities that this hypothetical town has. You can see it located here for drawing safe drinking water for the people of the town. So there are 3 different wells that are being considered, and there's the river itself that is running through the town that is a water resource. So all of these 4 options are being considered, and you're going to think through some of the contamination problems coming from industrial site near here and a cattle feedlot, in order to understand which one of these water sources is going to be the best, the safest, and cleanest for the town to use. So that's what you're working through here. So you're basically doing some analysis of groundwater flow to think through how to solve a societal problem that we think through whenever we drill a new well or consider, where our water supply is going to come from in general. The third part of the lab, part C, is looking at this interactive map online. So this is just an image of what it should look like once you're zoomed into the Fresno area. When you pull it up, you'll be looking at all of California. And then there's some directions about how to display the data on the side so that you can see the information that I'm asking you to think through. So for the whole thing, you're going to think about the data in terms of depth. So depth to the groundwater table from the surface of the land. That's the information you're going to think about. That's what you're calculating in part A as well. And then you're going to display the data in a couple of different ways, both as point data, so places where there's a well and there's data being logged regularly of what the depth is, and then as a color ramp. So let me show you what both of those look like. Here's the website. Let me turn off the visuals for the moment and zoom back out. So you can see all of California. You could look at what you'll look at the end, the color ramp from this scale, and just get a sense of what California looks like. All right, so you'll see that the data is being displayed in the Central Valley. This is where we've collected data for decades, and so we have a long-term record. It's also where we're particularly concerned about knowing how deep the water table is and what changes there are to that depth, because this is one of our biggest resources for agriculture in the area, for water resource, for growing all sorts of different crops that are grown here. So if we zoom in now, which is what I'm asking you to do in the lab, to the Fresno area, you can turn on point display. And in order to actually see the values associated with it, I need to zoom in a little further. So once you are zoomed in far enough, you'll actually see the values displayed for how deep the water table is below the surface of the land at those particular locations. So in this case, for the first question, I'm asking you to think about which of these points is closest to Clovis Community College, the main campus, and tell me how deep, therefore, the water table is at that location. You will also consider the difference between sort of the Fresno area and how deep the water table is in Madera, not too far away. And for that, I'm asking you to actually use the color ramp. That's a little bit easier way to look at that information. And then for the last question, you're using both of these data sets to help you zone in on where is the shallowest depth to the water table in the greater Fresno area, and what that value is. All right, so that takes you through to the end of this lab.